In this video, I'm going to continue with the third degree price discrimination. However, this time I'm going to have an example where the demand curve is a downward sloping linear demand curve. All right? The logic will be exactly the same, but the discrete time is, well, a slightly different framework. So I wanted to solve the third degree price discrimination problem in this framework as well. So I'm going to answer a bunch of questions in this video. So the first question is that there are two groups of customers that the monopolist is facing. The monopolist cost is zero for simplification, so no marginal cost, no fixed cost. So these two groups of customers, you can call them students and professionals, for example. Each group has these demand curves, all right? Well, then the question is, one, if the monopolist is allowed to price discriminate, which is third degree price discrimination, well, then what would be the price for each group? And how much or how many, what is the number of quantities that the monopolist would sell to each group? And then I am going to also consider the case where what if the monopolist is not allowed to price discriminate and instead charges the uniform pricing, meaning every customer pays the same price. So I'm going to find the optimal monopoly price and quantity in the uniform pricing case as well. And then the third part of this question, I don't know if I will do it in this video or in the next video because it may take a little longer. I am going to calculate the surpluses, the consumer, the producer surpluses, and the deadweight loss in the price discrimination case and in the no price discrimination case, and then compare these. All right, so let's get going. Well, in the third degree price discrimination, given that we have two groups, well, we start with writing the monopolist profit function. All right, so the monopolist profit function is basically revenue from each group minus the cost. All right, that's it. Well, the revenue from each group is basically the price for each group, which is given by the inverse demand curve. So it's 25 minus 4 Q1 times the number of quantities that the monopolist can sell to group 1. All right, so it's Q1. So that's the revenue from group 1 plus the revenue from group 2. It's going to be price 75 minus 12 Q2 times the number of quantities the monopolist can sell to group 2. And then minus cost, well, there is no cost in this example, so that's the profit. You could maximize the profit from the first group and the profit from the second group separately and then bring everything together. I mean, you could do that, but in general, don't do it. Write one profit function for the monopolist because the cost function could be a slightly bit more complicated. For example, the cost of producing quantity 1 and quantity 2 could be Q1 plus Q2 squared, for example. All right, so that would make the optimization problem sort of dependent. Is like the optimal quantity 1 will influence the profit from the second group because the cost of Q1 also, so you see what I mean? So you can't really separate the profit function always. So for that reason, always try to write down just one profit function, which makes sense. This is monopolist, one firm, and therefore it has one objective, which is to maximize the profit. And the profit has two resources, all right? So the group 1 and group 2. So just add them up, all right? So this is the profit function. Well, how do I maximize this function? Remember, notice that we have two variables, Q1 and Q2. So this is a function with two variables. Well, its optimization is simple. The first order conditions this time, we basically take the derivative of the profit function with respect to quantity 1, set it equal to 0 and solve for quantity, Q1, and then we also maximize with respect to the second quantity, All right, so the first order condition for the second quantity. So take the derivative with respect to Q2, set it equal to 0, and this time solve for quantity 2. All right, so that's it. That's all we have to do. No need to check the second order conditions because given that the demand curve is linear, the profit function will always be concave. All right, so you don't need to worry about the second order conditions. So I skip that step. If the demand functions were not linear, well, then we would need to worry about the concavity, I mean the second order conditions. All right, so what is the derivative of this function with respect to Q1? Well, this part has nothing to do with Q1, so its derivative will be simply 0. So the derivative of this part matters, which is 25 minus 4 Q1 squared, so it's going to be 8 Q1. Set it equal to 0, solve for Q1 means Q1 equals 25 divided by 8. All right? You don't need to calculate this number, all right? So you don't really need a calculator, just really leave it as a ratio, all right? And then here, again, I take the derivative with respect to Q2, so this part does not depend on Q2, so its derivative is 0. So this part, the 75 Q2, right? I am distributing Q2 over these two terms. So its derivative is 75. And then 12 Q2 squared, so its derivative 24 Q2 equals 0, means Q2 equals 75 divided by 24. Try to simplify it if you can. Well, both numbers are divisible by 3. So if you divide this by 3, you're going to get 25. And if you divide this number by 3, you're going to get 8. So 25 divided by 8. All right? So, yeah, that's correct. So apparently, both quantities will be the same. All right. Well, what about the prices? Well, here, in order to find the price for group 1, you have to use the demand curve for group 1. So this is the demand. If Q1 is 25 divided by 8, so the price is, therefore, 25 minus 4 times this quantity. So 4 and 8, we're going to have, therefore, 25 divided by 2. So the price is 25 divided by 2, right? 12.5. But just leave it as is. I mean, you don't really need to find the exact number. I mean, this is an exact number. You can just leave it as a ratio. Well, given that this is quantity 2, in order to find the price in this market, what I do, I just plug it to the demand curve. It's 75 minus 12 times 25 divided by 8. All right? So this, you can divide it by 4, so you're going to have 3. You can divide it by 4, so you're going to have 2. So what I have is 75 over 2. I'm subtracting it from 75, so the price is 75 divided by 2. All right? So apparently, the monopolist is going to sell the same number of quantities in both markets. However, one market is going to one market price will be higher 3 times more than the second market. Okay? So, I mean, it's always the best strategy. You know, once you're done, you just sort of summarize your findings. All right? Let me put it here because later I'm going to use it. So the quantity 1 is 25 divided by 2. Quantity 2 is, again, 25 divided by 2. And the price 1 is 25 over 2, and then the price of 2 is 75 divided by 2. All right, and then if you like, you can just take this all into square. So this is if the monopolist is allowed to price discriminate these two groups, third degree price discrimination. Now, part 2. What if this monopolist is not allowed to price discriminate? So the uniform pricing. All right. So let's take a note here. Price discrimination. All right. So now I'm going to find a uniform pricing case. Uniform pricing. Okay. So So in order to find the uniform pricing, actually, this is equivalent to solving monopoly problem, right? All I have to do, find the demand curve. The cost is already given, which is 0. So I need to find the market demand curve. All right? So how do I find the market demand curve? All right, so there are 2 groups, and each group has a demand. So the market demand is the aggregate demand. I mean, just the sum of these 2 demand curves, all right? Well, how do we aggregate the demand? Well, for any given price, we find the quantity demand at each group, and then we add them up. We change the price, and then find the quantity demand in each group, add them up, all right? Be careful though, the quantity demand will never be negative, it's always be positive. All right, but for this question, it's just safe to add the quantities, the quantity demands. Well, however, these are prices, right? I mean, these are inverse demand curves. In order to find the aggregate demand, I have to invert those functions and find the demand curves, not the inverse demands, the demand curves for each groups. So how do I do that? Well, the demand curves are going to be basically Q1, which is a function of P1. So how do I do that? I pull 4Q1 to the left-hand side and send everything, I mean P1, to the right-hand side. From now on, I don't need this parenthesis Q1 because this parenthesis Q1 just indicates that P1 is a function of Q1. All right? So I have a function. This is the function. My function's name is P1. And this function is depending on a variable which I call Q1. So this Q1 is just a description of my function. All right, so just ignore that. So send P1 to the right-hand side. 25 stays where it was. So this is 25 minus P1. I always want to leave Q's alone. So divide both sides by 4. So what I'm going to get is Q1 equals 25 divided by 4 minus P1 divided by 4. So that's the quantity demand for group 1. Well, exactly the same strategy. I take 12Q2 to the other side. All right, send P2, again, ignore the parenthesis Q2. Send P2 to the right-hand side. 75 remains where it was. All right, and then I just want to leave Q2 alone. So Q2 equals 75 divided by 12 minus P2 divided by 12. All right, you can make simplification here. Let's ignore for a moment. All right, I don't know. Well, let's ignore it. So given that these are the demand curves for each group, what is the aggregate demand? Well, then the aggregate demand is Q1 plus Q2. I'm going to denote it as capital Q. All right, so what is that equal to? I just basically add those numbers up. So it's 25 divided by 4 plus 75 divided by 12 minus P. Okay, so here you don't need to write P1 over 4, P2 over 12. Why is that? Well, because we are looking at the uniform pricing case, the monopolist will charge the same price across all the groups. Right? So that's basically the case where P1 equals P2, which we denote as P. All right? So therefore, whenever I see P1 or P2, I'm just going to put P. So that's going to become P divided by 4 minus P divided by 12. All right? All right, well, because these are 4, these are 12, multiply these 2 ratios by 3. So the total demand is 75 times 3 plus 75, all right? So it's 150 divided by 12 minus 3. And so because both are minuses, it's going to be sort of addition of 3p and p. So it's going to be 4p divided by 12. You can simplify it. Well, let's do that. How so? Well, 4 and 12, that's 3, that's 1. And I can divide this by 4, so it's 3. And if I divide this by 4, okay, so that's a problem. Let's divide it by 3. So I have 4. Let's divide this by 3. So I have 50, right? Let's divide this by 2. I have 2. Let's divide this by 2. I have 25. So let's leave it as is. Q equals 25 divided by 2 minus P divided by 3. Now, because I'm going to write the profit function, I would like to sort of inverse this and find the inverse demand curve. All right? How do I do that? Well, this time I pull P over 3 term to the left-hand side, send everything to the right-hand side, 25 divided by 2 minus Q. And I want to leave P alone, so multiply both sides by 3. So P equals 75 divided by 2 minus 3Q. Okay, I'm sorry for all those non-integer numbers. Well, sometimes it happens, but do never try to use a calculator and calculate those ratios. All right? Just leave them as is. Trust me, it's easier. At least in my courses, I don't allow calculators, so you shouldn't really calculate those. I don't know other professors, how they operate. Okay, so the profit function of the monopolist, when it charges uniform pricing, is therefore the price, 75 over 2 minus 3Q, times the quantity, the capital Q. All right, so that's the total quantity. And no cost, remember? So it's a simple profit function. All right, so the first order condition is del pi over del capital Q. Set it equal to 0 and solve for Q. So the derivative of this fellow is 75 divided by 2 minus 6Q equals 0. So Q equals 75 divided by 12. So 6 times 2, 12. I can simplify that. Let's divide both by 3. This is 25, this is 4. So therefore I have Q equals 25 divided by 4. All right, so if you remember, the quantities here was 50 divided by 2. So it was basically 25. However, here the monopolist is producing much less and selling much less. All right, so the same market, but the aggregate, the total quantity is higher here, and the total quantity is lower. So it's basically 1/4 of the price discrimination case. All right. So that kind of implies that the inefficiency should be bigger in this case. What about the price? Use the demand curve for this. All right. So this is the demand curve, the aggregate demand curve. 75 divided by 2 minus 3 times Q, which is 3 times 25. I mean 75 divided by 4. All right. So because this is 2, this is 4, just multiply this by 2. 150 minus 75, it's going to be 75 divided by 4. That's the price. And as you see, it's different than, it's higher than this, all right, but lower than this. All right, so this is higher than this. Sort of the in-between, all right? I'm in between these two, the price. Okay, so we found the part A and part B, so let's summarize. So if it is a price discrimination, I mean if the monopolist is allowed to price discriminate, the first group is going and the second group will get exactly the same quantities. The first group's price will be 25 divided by 2, and the second group's price will be 3 times more than this. However, if the monopolist is not allowed to price discriminate, well then the quantity will be, the total quantity will be 25 divided by 4, which is basically a quarter of the aggregate quantity here in the price discrimination case. And then the price is going to be 75 divided by 4, which is higher than this but lower than the second group. All right? The second group is the rich guys in a sense. So this is a non-student group and this is the student group. So this is exactly what happens. If the monopolist cannot price discriminate, it's going to charge a price where most of the students at least, are not going to be able to purchase. Most of the students are not going to be able to purchase the good. All right? It's going to be too expensive for them. However, if the monopolist price discriminates, what happens is that, well, the monopolist can charge low price for the students, so most of them, again, not all, but most of them will purchase. And it allows the monopolist charge even higher price for the non-students, and they still can purchase. All right, so, okay, it's been 20 minutes, so I think I can go another 5 or 8 minutes. So let's calculate the dead weight losses, but maybe I should just cut it and make a new video. All right, so let's do it. So I'm going to stop here, and I'm going to calculate the consumer surplus, producer surplus, and the dead weight loss under these two scenarios in the next video coming up, okay?